Hello everyone, welcome to Project Growth. This is me Simran Anand. I make YouTube videos related to the field of artificial intelligence and data science for Project Growth. So in today's video, I'm going to talk about natural language processing, give you an overview of how natural language processing can be leveraged to solve various use cases in today's world, and also would be demonstrating a short project so that it would be helpful for you to understand the various terms involved in NLP, and you would also get an idea and a clear understanding about how NLP can be leveraged to perform useful tasks. So, firstly, to begin with, what is NLP or what is natural language processing? Natural language processing is a convergence of artificial intelligence and computer science realms. So, basically, put in layman terms, it is to understand human language. So we know we can interact with machines via the language. It's not only via the keyboard and the mouse through which we interact with our systems, but when we interact with our systems through text as well as through speech or sound, that is where natural language processing is leveraged. So you might have seen the application of natural language processing is in various domains. For example, various businesses are incorporating natural language processing into their chatbots. So we see various websites these days, and obviously most of them are embedded with a chatbot or a virtual assistant. So we know that a chatbot or a virtual assistant is leveraging the concept of natural language processing. And there is a lot of NLP techniques which comes into the picture there. So what exactly is NLP solving, and what are the various concepts related to NLP? As I've said, NLP, it involves computer science, artificial intelligence, and also computational linguistics into it. So before delving into NLP, we must also be aware of the key terms which are related to linguistics. So there are terms like tokenization, lemmatization, stemming, and all such linguistic field of words. And also coming to the AI part, we need to have a clear understanding of the NLP pipeline. That is how exactly we are able to deploy our models, starting from the data collection to the deployment phase. How is the NLP pipeline being built? And how are the machine learning algorithms being leveraged to solve NLP problems? So such a convergence of these both fields, which is computational linguistics and artificial intelligence, so that we could understand, process, and manipulate human language, which is natural and complex for the machines to understand. So we're going to understand the human language, which is not only through text, but also through speech and voice commands. That criteria, that scientific technique is done by natural language processing. So when we really want to talk about the natural language processing, the various applications of natural language processing, there are a variety of natural language processing applications. So chatbot, as I've started my discussion with that, chatbots and virtual assistants. These days, they're not only limited to the educational industry, but you see that AI, in fact, is being used in various of the domains. So there are various of the domains like healthcare, which make use of natural language processing, especially for their medical document, when they want to extract information from them. So document information retrieval and search engines, these are some of the other applications of natural language processing. There are applications of natural language processing, especially in the product domain as well. There are various product as well as service companies which are leveraging the NLP, power of NLP to for suggesting users about the products which would tailor to their specific preferences or interests. You might have heard about recommendation engines. So recommendation engines, they work solely on the concept of natural language processing. That is because once these machine learning models identify the sentiment behind the customer's feedback or the opinion, which is sometimes called as opinion mining, that is where they will get an idea as to what is the preference of the user. Now, talking about the recommendation engine in specific, it is going to understand the sentiment by leveraging sentiment analytics, and then by using concepts like item to item filtering or user to user filtering, that is similarity measures, it is going to then recommend customers with products and reviews. So that is where a lot of natural language processing is involved, because to understand the sentiment of customers, which is nothing but sentiment analysis, which is a core part of natural language processing, that is where we are using sentiment analysis, hence to identify the sentiment behind the text. Now this is not only the NLP application is not only limited to sentiment analysis, but or text classification. Rather, there are various other applications of NLP. You might have heard of Google's voice engine, which is Siri, and Amazon's Alexa. we give voice commands, and whenever we want to search anything very fast, in a very fast manner, then we depend on such speech to text engines, or vice versa, which is text to speech engines, to retrieve information. So information retrieval also does require and depend on the concept of natural language processing. So speech to text, text to speech, speech recognition, these all are the some of the applications of natural language processing where NLP is leveraged. So other use cases of NLP is also being seen in HR. So in human resources, when we see that there are a lot of candidates are applying, you must have heard of the ATS, or applicant tracking system. So it extracts the keywords from the resumes, thereby making the process of hiring and recruitment very user friendly. The end user experience is also enriched through the process of artificial intelligence in this way, because by once the candidate is uploading their resumes or their CVs, the important keywords are analyzed, extracted by the natural language processing tool in such a way, in that way the candidate's hiring process is also speeded up. This is one of other applications of NLP in the human resources domain. There are several other applications of NLP in various domains. So when I've talked about the speech and also the text, there is also spam filtering. You must have heard of filtering the spam messages or email as spam or not spam. So identifying toxic comments, identifying and classifying such texts to monitor properly. That is also done by natural language processing. To put it simply, it is all dealing with the understanding and processing of human language, which is through text as well as to speech commands. So that was all about gist of natural language processing and its applications in today's world. Before we get into natural language processing, there is a lot of key terms to be understood, which I would be demonstrating when I would be showcasing, when I would be demonstrating the project. I would be also explaining the terms related to natural language processing and the steps involved in NLP. So this is a small blog which I've written, and I've just mentioned here what is sentiment analysis and what exactly natural language processing does, how it is able to solve business problems in today's world. The most important, the critical use of NLP in businesses is for the businesses to maximize their profit so that they could make appropriate decisions by understanding the feedback from the customers about their products and services. So whenever we get feedback in the form of large number of texts, we do not have the time, or the businesses do not have the time to skim through each and every comment on their product and service. So we need a mechanism, or we need a machine to do that mundane and monotonous task for us. So the task of analyzing all the customer reviews by using a lot of natural language processing techniques in Python. There are a lot of libraries which do that for us, like feature extraction is going to be done, and there is topic modeling. All such is going to be incorporated into by our machine learning model, and that task of sentiment analysis is automated. So this automation seen in the textual arena is done by NLP. So this is a short introduction about sentiment analysis. And as I was saying that NLP is an integral part of linguistics, we need to be aware of few terms. So let me just give you a gist of what exactly are the few terms you should be aware of before getting started in natural language processing or any project of NLP in general. So there are terms like tokenization, stemming, lemmatization, syntax, semantics, phonetics, and many more as such. So what exactly, first of all, whenever you talk about a body of text, you know that I've said NLP deals with textual data. So there is a collection of text or a body of text. Another word for the body of text is called as corpus. Plural is corpora. So whenever I say corpus of text, because a model, you're going to train a model on a text, on a connection text. So the body of such text is called as corpus. And there are various tools for natural language processing, especially for feature extraction. We have various mechanisms, like to name a few. There is TF-IDF, term frequency, inverse document frequency. Then there is word-to-vec model. We have the BERT model for word embedding, and many other such libraries which are available in Python. But then, and even for tokenization, stemming and all. So a few important libraries in Python, as you must have heard about, is NLTK, which is Natural Language Toolkit, SPACY, and so on. So these also are trained on a corpus of words. You must have heard of that. So corpus is a body of text. And then what is tokenization? Now, that it is a technique of breaking a sentence into individual tokens or characters to identify named characters like entities. So one more, as you can see here, named characters like entities. What does this mean? So there is a application of NLP, as I can see here, that is NER, named entity recognition. That is where it is an application of NLP which helps us to identify what are the entities, to recognize what are the entities present in the corpus of text. To put in simply words, I can say that there are various entities, or there are various parts of a sentence, like there are nouns, pronouns, adverbs, adjectives, and so on. So the various parts of a sentence or the parts of a speech have to be labeled appropriately by a model, and that task is going to be done by an NLP model. But before doing that, you need to first split your first the corpus of text, the body of the text you have, which can be either a document or it can be a text, it can be a paragraph as well. So you're going to convert that paragraph, simplify or break that paragraph into sentence. The sentence gets further converted into tokens, a number of tokens. So the technique of breaking sentences or a large chunk of text into smaller chunks of text is called as tokenization. The smaller chunks of text is called as token. So for example, as it is mentioned here, the named character like entities, which are noun, pronoun, article, etc. of a sentence, these are nothing but the tokens of a sentence. So if I say this is a red book, this is a red book, each word of this sentence is treated to be a token. Simply put, it is a word of a sentence. Coming to the stemming. Now, once I've said that a sentence is already broken down, now considering the word. Now, do not consider the sentence as a whole. Now, consider the word. For example, if you take a word like running. Now, running is a word. How do you convert running to its stem word? Now, the root form of the word. So, the chopping of the ends of the word, which is the suffixes of the word. In some cases, it can be the prefixes. But chopping off, the process of shortening, that is stemming of a word to its root form of the word, is called as, or the stem form or the base form of the word is called as stemming. I would also highlight the difference between stemming and lemmatization once I explain what is lemmatization. But for now, yes, stemming, as it says here on the next line, this does not always produce words which are meaningful. Hence, lemmatization is preferred. That is because if I say running, sometimes what happens is it does not get converted to the root form of the word as run. Sometimes it just removes the part of the additional suffix of the word, but does not make sense. The root form of the word does not make sense. For example, for running, it is run. But then if I say there is a word called better, better should, the root form of the word better can't be just chopping off the end of the word and returning bet, but rather the root form of the word better should be something which makes sense, or a canonical form of the word, which is a lemma. So in lemmatization, it is also similar to stemming, that is the process of shortening a word to its base form. But the base form here is called as a lemma, which is a canonical form of the word. And that citation form of the word is something which is more meaningful, ensuring the semantic of the word and not only the syntax. So, yes, coming to semantic and syntax. Semantic refers to, in simple, it refers to the meaning of the word, whereas syntax refers to the set of grammar rules, the grammatical rules associated with the structuring of a word or structuring of a sentence or text. So when we say lemmatization, it is shortening a word to its base form, which is called a lemma, maintaining the and also ensuring the semantic of the word. So if I say better, it gets converted to good, because the lemma of the word or the canonical form of the word better is good. And for running, it would be chopped off and lemmatized as run, because that is the base form of the word. So in such scenarios, lemmatization is also better than stemming. But sometimes stemming is the pros of stemming over lemmatization is that stemming is fast to process. So these were the two important techniques of natural language processing you should be aware of. Coming to the phonetics, phonetics refer to the sound or the pronunciation, the verbal pronunciation of any word, that is referred to as phonetics. And that comes into picture when you are dealing with speech recognition or anything which deals with human voice. That is where human natural language voice, that is where phonetics comes into picture. Another important term which you need to be aware of in natural language processing, where you will be seeing, is recurrent neural networks, because neural networks, you know that it's a deep learning aspect. So we need to train our model on we need to train our model using some algorithm, and for such cases we use recurrent neural networks for any textual data. They go hand in hand, NLP and RNN. So what is this recurrent neural network? I will just give you a brief about it. Recurrent neural network is a type of neural network which is a deep learning, phenomena, and it makes use of sequential information. The word says it, recurrent. Recurrent means something which is repeating. Since it keeps repeating itself for a sequence of information, word sequences, so that is why it is called as recurrent neural network. So it works and deals with sequential information or sequential data, where the data, we can say that the data is continuous and it is in textual form. So since it is sequences, it is dealing with sequential data, it is very much important for the RNN model to remember the previous information. So we know that a current state, there are various states of or layers of any, that any neural network has various layers: the input layer, hidden layer, and the output layer. So we can say that the succeeding layer of the neural network should be aware and should be aware of the previous layer's output. So that is what is important in a recurrent neural network. It should be able to memorize information. So memory is very important aspect of any recurrent neural network when we are building a model, as you would be seeing in one example, which I'll be demonstrating today. So that is something I would like to enlighten you about before starting with this project. So now coming to the fundamental steps in the analytical process in general, before starting as I'll be starting the tasks of the project also, it will become more clear to you. But before that, in general, as any machine learning pipeline, we know that to build an NLP pipeline or a natural language processing pipeline, the various steps which are involved are the data collection. First starts with the acquisition of the correct data, because it is very much important to maintain the quality of data. So data collection is important. Then following that is the text pre-processing, which is using NLP techniques like listed above. Tokenization, levitation, stemming, imputations, which are filling the outliers or the missing data, understanding the syntax and semantics of the language. That is the text pre-processing, which is handled by NLP. Then the next one after doing this is something which is more important, and that is feature extraction. That I have not missed, that I've just not mentioned here, because sometimes we are going to use pre-trained models which are already being trained, and then going to just fine tune the parameters of the pre-trained model. For example, Hugging Face. But then feature extraction is something which helps us to understand the what are the exact what exactly is the model looking for. So when we understand what are the attributes, the features required, we can perform feature engineering or feature extraction to make better. For example, IDF, TF-IDF, or word-to-vec, bag of words. These are such feature extraction models where the text of any human language, when we are inputting our input, text in the form of strings, text strings. We know that computer machines cannot understand, or it is not understandable with the machines for the human language, because our human language is pretty complex. So for it to simplify or to make our human natural language in the form of text easily in a format which is easily understandable by the machines, and we know that the computers can only understand 0 and 1. They only understand and work on binary data. So the process of converting, or rather we can say encoding the data, the text into a number, into a numerical form as a vector, that is called as one-hot encoding. There are various other names for it. Like we say that is feature extraction or word embedding. But then that can be done by techniques like one-hot encoding, which is pretty common. Then it can be done by word-to-vec, count vectorizer, TF-IDF, and various other approaches. So word embedding, that is basically taking care of converting each text into a numerical feature or into a n-dimensional vector representation for that text by assigning it a numerical value. That is also a part of the very important step of feature extraction or feature engineering. Then we perform exploratory data analysis to understand what are the various attributes of data, what is the shape of the data, shape and size of the data, exploring the data visualization is also part of this, because we're going to plot various graphs as such, like word cloud, which also helps us to understand which is the most frequently used word in our entire sentence, and so on, in our entire document as such. So finally, after the data exploration, we need to train our model. Now comes the modeling part. When I say modeling or data modeling, that is where I'm going to apply machine learning algorithms. So to apply machine learning algorithms, we are fitting our model with data which is trained. And to fit our model with data, or before applying machine learning, we know that it is a common, as you will be seeing in the project, we perform train test split. So that is, we're going to not use the entire data for training, but then rather we're going to split the data like 80% or 70 to 80% as train data, and 10 to 20% as a test data, which is held out for testing purposes. And also, one important aspect to understand is that this sentiment analysis is a supervised machine learning algorithm, because the model is going to be trained on labeled data. It can also work for like topic modeling. On the other hand, topic modeling is also a important part of natural language processing. It's a use case of NLP rather, which helps us to assign or basically model topics, but that is a unsupervised learning algorithm. There are various other algorithms in NLP, like text summarization. This is another use case of natural language processing, basically to summarize our text into something, into a simplified manner, so that we could get a nutshell of what the content is all about. Sometimes businesses and sometimes even the educational industry do not have that much time to skim through all the documents or to skim through all the paragraphs present in a document. So we need some mechanism, as I've said, to automate this process and to give us a summary of what the entire text present in the document is all about. For that, we are going to use text summarization, which is another use case of natural language processing. So coming to the evaluation and deployment, once we have trained a machine learning model with any algorithm or using a deep learning, we have built our neural network, compiled the model by building a sequential neural network, which is recurrent neural network in our case. We are going to evaluate the performance of the machine learning model. So how are we going to evaluate? So once there are various metrics to evaluate, the common one being accuracy. We can evaluate the performance of a model. That is how our model is performing on the test data. So once we have trained it on our trained data, we need to check if the model is going to be predicting a correct output or generalizes well on our test data also. That is going to be evaluated using metrics like accuracy, precision, recall, F1 score. These all are a part, as you would be knowing, as part of the metrics for evaluation of our model. So after understanding all of these aspects comes the deployment phase. Once we've understood that the model is performing well on our test data, we go to the next step, which is deployment. And deployment can be done on the cloud using various cloud services. And then also we can operationalize the model. But then if we find that there are flaws or our model is not performing properly, because sometimes what happens is there are various sometimes our model is not able to perform properly on the test data, or not able to generalize well, but rather it is showing a very good training accuracy, but the test accuracy, the validation accuracy is not up to the mark. Over there we say that the problem of overfitting comes into picture. Now, what is overfitting? It is a common problem, especially when we are dealing with machine learning models. So that is where overfitting comes into picture, either when we have less training data. So whenever the training data is less, or the quality of data is not up to the mark, the data is very noisy. Because of the noise, the model also is trained on the noise. The model captures the noise while training and then is not able to generalize or give us a proper expected output on the testing phase. So that is where overfitting comes into picture, where our model performs well on the training data but does not perform well on the test phase of the testing data. So to overcome overfitting, there are various approaches to and solutions. I will be talking in detail in the upcoming videos, but to give a gist about it, there are solutions like hyperparameter tuning, regularization, validation, which is k-fold cross validation. That is, we are going to, rather than using like train test split, we are not going to use the entire training data for our training. We are going to split cross validation in the sense we are going to make k-fold cross validation in the sense we are going to make k folds, or we're going to divide our data set into k times, and then we're going to check k times how the model is performing on every fold. We divided the training data into certain k folds, so we're going to check how the model is going to be generalizing on each fold, and then the summation, or basically the averaging of all these performances of the model on all the k folds is going to be giving us a general overview of how the model performs. So in such a way, by using k-fold cross validation or stratified cross validation, hyperparameter tuning, or simply increasing the data. There's a word for simply increasing the data, that is data augmentation. There's a technical word for adding more data. Whenever we fall short of data, we're going to add more data so that our model is going to be able to understand new features and is going to be trained well. So these are some of the ways in which the problem overfitting, which is very common, can be avoided. And then after this is all about talking about the evaluation, so that all such problems can be avoided. We can overcome all such problems. Then after deployment, we have making sound decisions and optimizing the model. We have understood the model, what is it, how the model is generalizing. We have deployed it. We need to also optimize our model. We have to check that the model is going to is we have to basically increasing the performance of the model, and this all is going to help us to make sound decisions. We can use all the we can also use all the generated insights from our training process from our project, so that the companies or various companies, businesses, organizations, even the healthcare domain, education, retail, and many to name, these all aspects of our day-to-day life, there are various people and organizations. They can make use of all such actionable insights from this data analysis of ours, the sentiment analysis, or the basic, we can say, the natural language processing task, which can help them to make sound and appropriate decisions to act upon. They could thereby, by doing this entire process of natural language processing, by understanding the customer's feedback, by interacting with humans, and by basically making the task of understanding the human natural language in a very simplified way. This helps us to get to know our customers very better, in a better way. So that is how we also can make proper conclusions and sound decisions after optimization. So that was all about it. This is a flowchart following my explanation about what are the various steps of the natural language processing pipeline. And after this, so this was all about it. I've just explained about overfitting and what is sentiment classification. Yes, one important part when I was talking about chatbots, now in general, NLP, natural language processing, it also comprises of two subdomains, which are natural language understanding, NLU, and natural language generation, which is NLG. So a chatbot, for example, whenever it takes a user's query as the input, it needs to understand the user's query or the text, which can be either in the form of text or in the form of voice. So the task of understanding or interpreting the human language is natural language understanding, where it takes into account the semantic measure, the syntactical analysis, parsing. Parsing is nothing but the syntactical analysis, then semantic analysis. This is done by natural language understanding. Whereas on the other hand, the domain of NLP, which is natural language generation, the task after understanding the user's text input by the chatbot has to map the intent. Basically, the intent is nothing but the category in which the context of the textual input of the user. It has to understand the context of the user and then give a proper an accurate response to the user's query. The task of generating the response as an action to the user's query by identifying the intent is called as natural language generation. It is important and it's basically a critical part of natural language generation, NLG. So these two are also a part of natural language processing, natural language understanding, and natural language generation. Another important aspect of where NLP can be leveraged is for question answering. There are various question answer generation systems where, given a prompt or whenever we have to find the answer. Now it is not only chatbot where we are expecting an answer or a response in as a response and reply to our question, but then there are various other applications of NLP, like search engine, for example. As I've said, search engine where we want to retrieve information. Information retrieval, in fact, makes use of such NLP mechanisms as well, because it needs to identify the relevant information, and that for that we are going to use knowledge graphs as well. It makes use of knowledge bases, knowledge graphs, and it is trained on lots of humongous amount of unstructured data. We need to understand this information, that the information and the data present on the internet, and especially that is which is going to be incorporated for NLP applications, it is in unstructured form. When I say unstructured it is not just tabulated or not structured well. It is really unstructured, having a lot of redundant words. Some words are having a lot of fillers, or we could say probably there is punctuation errors, a lot of symbols. It consists of symbols, emoticons. Our text consists of a lot of, nowadays emojis are becoming a popular aspect of every text we pass in. So we know that there are symbols involved, there are punctuation, hashtags, special characters. We need to take care of all this, and that is where another one other concept or another tool which comes into use is basically regex, which stands for regular expression, because it does what it regex does is pattern matching. It is going to be training the machine learning model and helping it to retrieve information by training on patterns, text patterns. That is where regex also comes into picture. So I've just given a brief overview about how the natural language processing is all about opinion mining, recommendation engines, which leverage these phenomena of natural language processing. And I was also talking about accuracy and the matrix. You can see here, this is the confusion matrix. So once we want to like test our data in the evaluation phase, this is when confusion matrix comes into picture, where we have true positive, true negative, false positive, false negative. That is for confusion matrix. And if there is a, in this case, I've used multi-class classification. So if there is a binary classification, a yes or a no, we know that it is either the response would be one of the two, a 0 or a 1, for example, yes or a no. But in some cases, we have multiple classes. So instead of just a text can just not be positive or negative, it can have another class which is neutral. Or sometimes we need a measurement scale where there are more than even two classes. Even in the demo I'll be showing, there are more than 5 classes. There's totally 6 classes. So that is where multi-class classification comes into picture. So that was all about it, how natural language processing is used these days, and information retrieval engines are also leveraging this concept. And to delve further into recurrent neural networks, we'll be using LSTM, which I'll be explaining what is what is LSTM all about. It is basically extended recurrent neural network itself. So this is the project. I'll be skimming through the code and explaining you the main concepts related to it, and also what each step does. So this is tweet emotion recognition. It is trained with TensorFlow as a library in Python, and the data set is tweet emotion data set. This is taken from Hugging Face. As you can see, you can just follow on my screen that this is the Hugging Face data set is trained on. It is a labeled, it is trained on labeled data. Hence, it is a supervised machine learning algorithm. We can say that we're using supervised learning here because it has text, that is a tweet in the form of a string, and label, which is numeric form. Now, before the label, it's actually the class label is supposed to be a emotion, because when we say tweet emotion recognition, we are expecting the class to be an emotion. That is whether a tweet or a text is categorized as positive, negative, neutral, or something like, if you see here, sadness, the emotion, sadness, anger, love, surprise, fear, or joy. So these are the 6 classes. But then rather we know that the machines cannot be trained on something which is in the textual form. So we need to convert at least our target label we need to encode it in the numeric form. So for doing that, we will be using, we'll be converting the text into the number form. So encoding the text in the number form to give it a vector representation, and that is label encoding, which is being used here. So we are going to assign labels. We're going to assign the labels with indexes, or basically values, numeric values. So this is the data set. You can see the summary of the data set here. You can just go to the Hugging Face site and go to the emotion data set. That is where this is a sample data set in which we have used here. So this is setup and imports. As you know that we are training on the Hugging Face NLP package. Finally, we are going to also import the packages. So these are the packages being imported: TensorFlow, Matplotlib, NumPy, all these packages. We are going to also define functions. Now these functions, which is show history and show confusion matrix, although they're not being used right now, we are going to make use of these functions in the later part. Because when we want to show the history, as I have said, recurrent neural networks, it depends a lot on the previously trained data. So in order to see the history, this function is going to come into picture. Also, show confusion matrix in the evaluation phase. This is how we are going to define it, our Python function. Then talking about the importing the data. Once we have imported the tweet emotion data set, we have to create the train, validation, and test sets. This is before we leverage or use the machine learning algorithms. We need to first perform train, validation, and test sets. We need to split the data. That is going to be done, followed by extracting tweets and labels from the examples. Since as I've shown, our data set consists of tweets and labels, we need to extract those for training purpose. So this is how it is done. We're going to load the data set, which is named as emotion data set here. This is the data set. The overview of how the data set is going to look like. We are going to divide the data set or split the data set into train data set, validation, and test data set. Then get tweets. This is the function for getting the text as well as the labels. This is going to return the tweets, each of the tweets present in our data set, followed by their labels. The labels are in the textual form for now because we haven't converted them yet into the numeric form. They are into the textual form. As you can see, I am feeling grouchy is labeled as anger. because grouchy is a word which is standing for cantankerous. It is something which is complaining. So in a very irritated mood. That is why it is labeled as anger. Followed by tokenization. Since I've explained you in my in the middle of my video, I had explained what is tokenization. Basically, splitting a text into smaller chunks of text. So that is what is done here using the tokenizer library, and that is imported from the TensorFlow pre-processing. TensorFlow pre-processing package. We're going to import tokenizer, and then this is how tokenization is done, where each word in the sentence is treated as a token. Now comes one integral task of pre-processing, which is padding and truncating sequences. Padding is a very, very common word you must have heard about while dealing with images. So when we want to deal with the processing of images by convolutional neural networks, which happens, you know that there are some images which are very short, small images. One is some images which are very large in size or in dimensions. So in such a way, we need to pad. We need to we need to enhance the image size. So that is done by padding. Similarly, padding in textual information, textual context of our project is basically we are going to pad the sequences which fall shorter. There are sequences which are not of uniform length. We have longer sentences, shorter sentences. So we need to ensure that all the sentences are having uniform or equal length. So for doing that, we pad sequences, basically checking the length of the tweets, and if they fall shorter than the normal length, we are going to pad them with zeros. We can pad them with pad is basically adding the or extending the length of the data item. So here it's a text data. We're going to extend the sentence length by adding some values, which can be in the form of zeros. We can pad the data values with zeros. After converting the labels to labels, we have to first convert the labels to the numeric form. Then we have to pad them, and padding will return a sparse matrix of values, as I'll be showing you. So truncating sequences. Truncating is removing or shortening the sequences. So whenever we have longer sequences, we need to truncate them or remove the irrelevant parts when we don't want. Sometimes we have punctuation. Although this text we are training this model on is already pre-processed, since I've taken it from Hugging Face, most of the pre-processing aspect is already done, and we have to just fine-tune our model with parameters, because we are making use of the Hugging Face model data set. But then sometimes it happens that the sequences, there's a lot of pre-processing required. So sometimes it involves a lot of punctuation marks, characters, special symbols which need to be taken care of. Also, there are something like converting the lower cases into the upper cases, or upper to lower cases. So such text pre-processing and text mining is going to be taken care of. So truncating sequences is basically shortening the length of the sequences. As you can see in this function, we're going to convert them, is basically divide them into bins. Binning is a data standardization concept, or to normalize the data, basically, so that it's of uniform length. The bins are of uniform size. The bins have to be of equal length. Now, once we do this, we need to get the sequences. Get sequences is basically returning the padded sequences. After the padding is going to be applied here, as you can see, truncate is equal to post, padding equal to post. We're going to convert the tokenizer library is being incorporated here to convert the text to sequences. Finally, we are going to do the padding here, and the padded sequences are going to be returned by this function get sequences. Finally, we're going to get the sequences, which is nothing but the tokenizer and the tweets. So as you can see here, this is an array. It's going to be returning a numpy array for us. The output of this padded train sequence is a numpy array, and this is the format of it. So there are 0 values which are padded. So whenever you see a 0 value, you can understand that those are padded. And after this, we have the task of preparing the labels. So since our end goal is to achieve labels, or to basically, we need to assign, or we need the model to be able to accurately recognize which emotion the tweet is going to be falling under. So for doing that, we're going to prepare the labels. So creating classes to index and index to classes dictionaries. Dictionary is a pair, is consisting of a pair, is a data structure consisting of a pair of key values. So it consists of key value pairs, where the key is the tweet and the value is the basically the value is the index assigned to the tweet, or the label of the tweet. So in this case, when we see index to classes, the index to classes, the class is the type of emotion. So when we see sadness, joy, love, fear, anger, and surprise are the 6 emotions, as it is as we can see here. It is the set of labels in our data. All these 6 labels have to be assigned to indexes. Now, to be assigned to indices, we have to prepare the labels. Now, how is it going to be done? As you can see here, Class 2 index is the function being used here. We had defined it earlier. Now class 2 index is over here. It's going to assign each of this the emotion to a particular index. Sadness is assigned to 0, joy to 1, and so on. From 0 to 5, because index starts in Python also, the index starts from, indexing always starts from 0. So it is going to assign each emotion with a particular index or a labeling. So after doing that, we are going to now train our model. Now first comes to create the model. Now, after we have done the pre-processing part here, all the text pre-processing part is done. Along with that, we have also done the feature extraction part, because we understand in our data set we have just the tweet as well as a label, and we understand that these both are the features which are equally important. Sometimes it so happens the data set also consists of something like ID or some other columns which are not that of much importance to our machine learning modeling phase. So for those kind of scenarios where we want to eliminate some features or eliminate some columns and attributes which do not serve of much importance to us, we can eliminate them in the feature engineering phase or the feature extraction phase, where we are going to extract only those features which are of importance while training our model. So while building a model, so we see here text and label both were important, and feature extraction is done, followed by feature embedding, because feature embedding is nothing but the word embedding, which is converting the word and converting them into numerical values or vector representations of the word. That is nothing but the word embedding. So that is done. After doing that, we have to create the model and then compile the model. Now we have to create a recurrent neural network. As I've said, it works on sequential data. Hence, we are going to use the sequential network here to train on. And finally, we also need to know that recurrent neural network, it consists of what exactly? And you can see here there is a parameter LSTM. Now, we are going to make use of an extended RNN for our use case here for emotion recognition. It is LSTM. LSTM stands for Long Short Term Memory Transformer. So basically, LSTM is an extended recurrent neural network which is solves the problem of long-term dependency. As the name says, sometimes it so wants that we want the model to remember information or context which is in the past, in the history. But recurrent neural network sometimes does not have the capacity to memorize such information. In such cases, to solve the problem, because our data set is huge here, the one we have taken from the Hugging Face, it is very huge, having a lot of information, having a lot of content, where we have many tweets which are even very similar and differ only by some margin. So for that, to handle such scenarios, we need an advanced model where we have used LSTM. It is an extended recurrent neural network which solves long-term dependencies. It can memorize information even in the past. Basically, we know that the current state is dependent on the previous state, the history, as well as the current state. So it is able to memorize and remember information which is fed to the model from long in the previous layers. And recurrent neural network and or LSTM in general. So a recurrent neural network, it works on the encoder decoder architecture, as you would be knowing. So to put in short, encoder is where we go. The encoder aspect of the RNN is where it's going to first understand what is the text data. The input to it is the text data we are going to pass in. The text data is encoded into a form, or basically processed into a form which whose the output of the encoder is sent as the input to the decoder. Now the decoder is going to remember information from the encoder as well as its current state, and then going to generate a label which is the final output we want, the label or the emotion to be recognized for the particular tweet. So the input to the encoder is the tweet, whereas the output of the decoder is the emotion recognized. So that was what for now you have to understand this. And then when I was talking about the LSTM, LSTM also works in encoder decoder architecture, but rather than having these kind of layers, like you need to have hidden layers, rather for LSTM, we have cells, we have gates. So we have the input gate, the forget gate, and the output gate. So that was all about it for the LSTM. And you can tune in these parameters like 1000, 16, and so on. Whichever, this is a part of experimentation, which you can evaluate your model, check the accuracy, and then finally you can also fine tune this model, because this is a little bit, we can say this is a pre-trained model because it's taken from Hugging Face. More of the pre-processing part was already done because as you we haven't actually worked on the punctuation, the conversion of the lowercase to the uppercase and vice versa. And there's a lot of things which are involved in the pre-processing aspect. But then most of the part was already done in pre-processing. So I would have just showed you the important part, that is tokenization done. But there is lemmatization, stemming, that is all already taken care of in the data set. But then you can definitely you can fine tune the model here by changing the parameters here, whatever works out. But then after checking the accuracy, I found out that these were the parameters 1016 which work for our model, and that is why I'm demonstrating this for you. But the main concept here is you have to understand how to fine tune the model, because once you have understood how to fine tune the model and how to work around it, what are the various steps in NLP, it becomes really easy for you to solve any kind of problem, a business problem. By first you have to understand the business use case and identify which concept of the vast topic of natural language processing fits into that, to solving that problem. And coming to this, now back to the topic of this layers, we can see that this is embedding layer which performs the word embedding. Then we are using bidirectional LSTM network here. We are building the bidirectional LSTM network which has both feed forward as well as the backward layer, forward as well as the backward layers. And finally, the output layer, which is dense layer, and we need an activation function. We are passing 6 here. This cannot be changed here because we have 6 classes. This is the final output layer. And we know that the output layer should be having the number of classes. So the number of classes in our data set there were 6 labels. There were 6 classes. That's why, which are namely joy, sadness, and so on. So that's why we are passing 6 here. Activation function used is a softmax function because we are working on continuous data, but the output is single. The output cannot be both joy and sad at the same time, or both love and joy at the same time, although both love and joy resemble. Sometimes do resemble, but they cannot be treated equal, because we need to the model only has to return a single output or a single label or a category the text is falling under. So for that we are using softmax activation function, which is going to return a single output. That is why we are going to pass it into the dense layer, which is the output layer of our neural network. Then we're going to compile our model after building the model. Now to compile a model, we're going to use we're going to use parameters like loss, optimizer, and metrics. Now metrics totally depends on you. You can, like, if you have observed that your data is very having a lot of imbalances, there is a class imbalance problem where there is a particular class which is more in number than the other classes or less in number than the other classes, then we can go with precision and other metrics. But then the most common one is accuracy. So I have set the metrics here for our project as accuracy. Coming to the optimizer, Adam is the most tried and tested and suitable optimizer I would recommend for your machine learning projects. So it works very well and trades well, especially wherever you are dealing with machine learning and deep learning models. Adam works well. So this is the optimizer, and you have to also ensure that the metric accuracy is the highest by a model, is highest possible achievable. It should be possibly the highest one, and the loss should be minimized. So you have to keep maximum. You have to ensure that the accuracy is maximum and the loss is minimum. So we are using sparse categorical cross entropy. Now we are using categorical because we are training it on not on continuous data but on categorical data, because our data is consisting of categories, that is sadness. These are various classes: sadness, joy, love, anger. They are various discrete data. So that's why we are using category here. And loss is cross entropy, is a kind of loss here to minimize the randomness. So entropy is all about randomness in our data set. So we want to minimize. So we are using categorical cross entropy, which works better than the binary cross entropy. We are using the categorical cross entropy. Then model.summary, which is going to give us a summary of how our model is about, the output shape, the parameters passed, a brief overview of what we have already built our model about. Then followed by training the model. Now once we have emulated all these processes, now comes preparing a validation set and then training the model. Now for doing this, as you can see, we are training the model on validation. I feel like I'm still looking at a blank canvas, blank pieces of paper. This is treated as 0, as I have shown you previously that there were labels assigned to every class. So as you can see here, 0 is for sadness, 1 for joy, 2 for love, and so on. Now we saw that the output of the model after training it, it has detected as 0. 0 is for sadness. Now let us check if the sentence is actually predicted correctly or is actually trained correctly with the model. We are training, when we pass in the validation tweets, we see that this is the sentence or the tweet. I feel like I'm still looking at a blank canvas, blank pieces of paper. That is something negative or something sad, because while still looking at a blank canvas, the words like blank, these are the keywords which the model is taking care of. So by understanding this, the model has in our data set as well, we are training the model to identify such sentences as 0, that is nothing but sad. So we are going to fit our model to train it. Now, once the model is trained, as you can see, it is taking parameters like padded train sequence, labels, validation data, epochs. Number of epochs can be set by you, which can be fine-tuned. Like for now, epochs are nothing but the iterations, the cycles of training. So for now, we have trained it on 20 epochs. Callbacks, and after training phase is completed, we can see here that the validation, you can see here the accuracy is 91.23%, which is pretty good. For now, you can keep fine tuning the model and of course increase your accuracy, but just increasing and improving the accuracy by testing and experimentation is not only the end goal. You should always remember that the end goal should always be that the insights generated after all this, that is the insights generated by a machine learning model in the NLP pipeline, should be able to convey some information so that the companies will be able to make actionable decisions and can make decisions to maximize their profits by better recommending their customers or working on the negatives, and then taking such feedback and then working it out constructively so that the products and services can be improved. That is what is the main use case of NLP here. So as you can see here, that the accuracy is 91.23% of training, validation is 85.55%. So both are pretty close to each other. We can say that whenever the validation is nothing but the testing accuracy in our case, and the training accuracy is 91.23%, as both of them are pretty close with a loss of just 0.22, that is 22.86. That is a loss, which is pretty negligible compared to the accuracy we've achieved. But then, as I've said, you can experiment it, fine tune the model, and also try working with different data sets. So we have understood that the model will fairly perform better. Now to evaluate the model, we can evaluate the model through graphs as well, like area under the curve, ROC curve. You've heard about this, ROC, AUC. So what exactly? Now show history was a function which we have used in our in the starting of the code. I have created or defined a function, show history, so that which plots the graph. That is, it depicts the accuracy of the model plotted against the number of epochs it is being trained on. So as you can see in here, the training and the validation accuracy, the model is performing pretty well because there is no overfitting seen here. So overfitting is such a case where there is irregularity seen by the graph. Wherever there is irregularity seen or a irregular pattern in the graph, we can say the model is overfitting. But then there is a linear relationship, and we can see training and validation is almost same. It is performing. We can say that the model is able to generalize well on even the testing data or the validation data. So now let's test our model. After for testing the model, we are going to now take a random value. Now let's just take a random sentence from the data set. We're not going to feed the the model with something specific. Now we could like in the previous case, I had passed in the value, that is the fourth. As you can see here, tweets at 4, that is the tweets in the data set present at the fourth index was passed here. I am feeling grouchy was passed as the training, but for the training purpose. But in the testing phase or the validation and the evaluation phase, we are passing it something random. We want to check if the model is able to generalize on unseen data and also generalize on the seen data or not. So this is a supervised task we are performing. So let us pass any random text. So just using this random function here, and then the model should be able to give us the emotion. Now it should not be able to recognize the emotion of the tweet in the form of 0 or 1 or the index value, but rather be able to give us the class of that in the textual form only, because that is the end goal. So on testing this model, we have come to know that the model prediction is pretty good, because sentence says, I don't know if I should let go and feel that vain or should I wait and stay in vain. This seems to be something dejected, as we can see and understand, but then we do not have time because to skim through so many reviews and all. So what our machine is doing, that is it going to be training correctly? Let's see. Emotion is sadness. That is, in our data set, this sentence corresponds to the actual expected emotion is sadness, and even the predicted emotion of a model is sadness. So a model, since the predicted as well as the predicted emotion and the expected emotion by the model is same, we can say that the loss is very less, the error is very less, the difference between what is expected and what is predicted is less. So we know that a model is able to perform accurately, is able to give a good accuracy as was seen, and able to give us a correct output. Now to let's just plot the confusion matrix. We can see here this is a scale ranging from 0 to 1, where the different emotions are shown with different intensities are plotted against them as in the values of a confusion matrix, which is a matrix as you can see here. And this has all the 6 classes here. So that was all about it. To understand the NLP with this use case, which is tweet emotion recognition. Now remember that it need not be just tweet; it can be any text recognition. You can have customer reviews, product reviews, so that once we have understood what is the sentiment all about the customers, how is their feedback on a particular product of your company or your or basically hospital data. When we have hospital data, how is the customer giving feedback about the doctor or about the hospital services in general? The hospitals can make proper decisions. The organizations can make and improvise on their products. And then there's some organizations like the song playing organizations like Spotify, or the movie recommendation engines, as you would know, like Netflix, and organizations like Amazon, which work on products or services. They can understand the feedback of their customers, their opinion, by mining them, and then work on personalizing them. That is basically they can give personal recommendations and suggestions to the customers, so that the customers can tune in and give a better feedback. So that was all about it. Just about leveraging the several NLP use cases. This was the most critical and the most intriguing one I would like to demonstrate. Hence, I would just show you this. But then in the upcoming videos, I would be explaining you more about natural language processing, data science, artificial intelligence. Also, be showing you different projects and their use cases. Also, one thing to be noted here is that natural language processing is not only limited to this kind of tweet emotion recognition, but it is also having several use cases, like I've shown in chatbots, voice assistants, and other areas like text summarization and so on. So that was all about it. And one important mention, I would say, that do visit our Project Pro YouTube channel to learn more. Stay tuned for more updates. Project Pro is a curated library of solved end-to-end projects, where you would be able to find 3,000 code recipes which are verified, and so the project solutions are provided by top industry experts working in top global tech companies. Also, you would be seeing that the projects are not only having just the codes, which are 3,000 reusable codes, but rather they also are accompanied by guided videos, blogs. 24 by 7 customer support is available, and you could avail all our recipes, the code recipes, for absolutely for free. And also do subscribe to our channel, like and share. Also do avail the subscription and buy our subscription, which would give you an access to 250 plus solved end-to-end projects.
Project Pro, the only solution for solved industrial grade projects.